Hello to my amazing fifth graders. This is Mrs. E, and I am here to help you with page 3 and 4 of your fifth grade Home Connections book. Please be sure to put your name, and I really want you to do your fourth grade review page and also this page. You will be getting double points for your homework, bonus points. And on this page in your fifth grade book, we're going to be using all of our multiplication models that we've been reviewing and learning, but instead of multiplying just 2 numbers, often here we'll be multiplying 3 numbers. On the back here we'll be multiplying 3 numbers. So we'll look at that when we get there. But let's look at these multiplication connections. There's an example here. It says to multiply a number by 5, Marissa first multiplies by 10, and then she finds half the product. So we've definitely been reviewing our doubling and halving strategies. So this is a really good strategy for when we're multiplying by 5. So here she writes an expression with parentheses to show how Marissa would solve 24 times 5. So first she's going to do 24 times 10. She's doubling one of the factors, which means she has to cut the product in half. And cutting something in half is the same as dividing it in 2. So this is really easy. We can do that by just adding that 0. Instead of 24 units, it's 24 tens. So we add that 0 there. And then, so if that's 24 times 5, or sorry, 24 times 10 is 240. 24 times 10 is 240. We cut it in half because we don't want times 10, we want times 5. So we cut it in half, and I know half of 24 is 12. We've been really practicing our doubles and halves. So half of 24 is 12. So half of 240 is 120. So this is one possible strategy you could use when you're doing a times 5. So let's look at this next one. That was our example. So to multiply a number by 12, Carter likes to multiply by 10 and then multiply by 2. This is same as I do. I show this all the time in class. If I'm multiplying by 12, I take apart that 12 into a 10 and a 2, and I multiply by 10, I multiply by 2. So he's showing this here with an area model. So instead of multiplying 16 times 12, he's multiplying 16 times 10, and then 16 times 2. So let's write an expression to show what he's doing here. So this top part of the area model, this is 16. Remember, the dimensions are the factors. So here's 16 times 10. So let's write that down here in parentheses. That top part is 16 times 10. And then this bottom part is 16 times 2. So this is my favorite strategy, times 12, right? So now we have also 16 times 2. Now we know we need, these are each a partial product. It's a part of the whole product, and we need to add them together. So we'll just put a plus between there. Look how, oops, sorry, I'm a little off the camera. Look how fancy that looks. My 6th graders were writing expressions like that. So let's go ahead and solve it. What is 12 times 16? Well, I know 16 times 10 is, instead of 16 units or 16 ones, it's 16 tens, so I got to add a 0 there. So that's part of my product. And then 16 times 2, I happen to have this one memorized, but if you don't, it's not a super easy one to double, because when you double the 6, you get a 2-digit number. So just, if you don't have this memorized, stack them and add them. 6 plus 6 is 12. 1, 1, 1, 10, 10, 10, that's 30. So 16 doubled is 32. So now I have my partial products. 160 plus 32. If you're going to stack them up this way, remember to line up the ones, line up the tens. And now I know I have 6 plus 3 is 9. It is 192. So the full product is 192. These are my partial products. All right, thank you, Carter. I love the area model. I often do it like this, where if I have 16 times 12, I'll just split it apart like this. So 16 times 10 is 160 plus 16 times 2 is 32. And then I can add them together at the end. So this is just a little shortcut of your area model. All right, we have a different strategy here. I see a 99. Let's see what Sophia's doing. So to multiply a number by 99, Sophia likes, yep, that's what I was thinking. She likes to multiply by 100 because 99 is just so close to that very friendly number. And then she just subtracts one group of whatever factor she's multiplying by. So here's a picture of her thinking. So her factor is 8. There's the factor. The dimensions are the factors. So instead of 8 times 100, we know that, right? 8 times 100 is 800. She's going to do 8 times 99. So that's 1 less 8. So it's going to look something like this. Oh, let's look right here. It says write an expression with parentheses to show how Sophia would solve 8 times 99. So let's go one step at a time. First, she's going to do 8 times 100. So let's put that in parentheses. And we know that's 800. And then she's going to subtract one group of 8. We could put 8 times 1 in parentheses here, or we could just say minus 8. So we know now this is 800 minus 8. Well, it's going to be, if I was taking away 10, that would be 790, but I'm not taking away a whole 10. I'm only taking away 8. So that would be 792. So I believe we have 792. Beautiful. Okay, so applying our multiplication models and strategies we've been doing in class to some more tricky 5th grade work. Okay, let's look. This is a rectangular prism. It is a 3-dimensional figure. We want to fill in the dimensions. We know to find the volume, we multiply the 3 dimensions of the 3-dimensional figure. So base times width times height. So let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's one of the dimensions. This one's kind of hard to see. 1, 2, 3. And 1, 2, 3 up the side. So we have 9 times 3 times 3. Now we know, because of the commutative property of multiplication, also the associative property, that we can do these in any order we want. So I could do 27 times 3, or I could do 3 times 3 times 9. I like that one because I already know that fact. So 3 times 3, I'm going to rewrite this right here, 9 times 3 times 3. I already know that 3 times 3 is 9, and I know 9 times 9. If you don't know it, use your 9s trick. 1, 2, 3, 4, 5, 6, 7, 8, 9. Tuck that under. So we have 5, 5, 6, 7, 8, and 1, 81. So the volume of this rectangular prism is 81 units cubed. They're not squares, they're little cubes. Okay. Beautiful work, my friends. Okay, lots of multiplying by 2-digit numbers here. If you would like to grab a piece of scratch paper, I highly recommend it. I'm going to just use this paper here. You can use lots of different strategies here. You can use our new algorithm we've been learning. You can take apart the 10s and 1s just like we did over here to multiply by 13. Lots of different strategies. I'm going to rewrite this with the 13 on top. And I'm going to practice my new algorithm skills. So we know, because of the commutative property of multiplication, we can flip those around. And to do the algorithm especially, I like to have the number with more digits on top. So 2 times 3 is 6, and 2 times 1 is 2. So that's 26. 13 doubled is 26. Now look at this one. This is a double double. It's a 4. So 13 doubled is 26 times 4. You're just going to double it again. So if you can double 26, that's going to be the product there. I'm going to write it out with my new algorithm. 13 times 4, just using the space I've got. So 4 times 3 is 12, and 4 times 1 is 4, plus 1 more makes 5, 52. If you're still with me, I would love for you to pause, finish these out, see what you can do. This is definitely, I think, maybe the trickiest one. And then come back and we can compare strategies. So I'll flip this one. Oh, look, it's a double, double, double. Ah, my lights went off. Emergency. We have to move our bodies. So this is going to be the 4 doubled. If we double a factor, we have to double the product. So let's see, 52 doubled. I think that'll be 104. But let's try it with the algorithm. 8 times 3 is 24. 8 times 1 is 8. 9, 10. Add that 2 to make 10. There it is. 52 doubled is 104. So this is a double, double, double. Times 2 times 4 times 8. All right, how we doing? We're doing okay? Let's look. Oh, I love times 10. I don't have 28 ones anymore. I have 28 tens. So I can just add that 0 right here, add a place value. Oh, and this one will help me on this one. Look at this, my friends. My factor is not doubling. My factor is cutting in half. It's a times 5, just like we had in our example up here. In times 5, we found the times 10, and then we cut it in half. So let's try that strategy. Half of 28 is 14, and I keep my 0 because it's 280. Half of 280 is 140. Now, if you would like to check your work with our new algorithm, just for funsies, for practice, let's try it. 5 times 8 is 40. Put your tens up here and your 0 here. 5 times 2 is 10, plus 4 is 14, and there it is. We got a match. Okay, we're still building. What do you notice? This is now 28, 28, 28. We're still on 28. And here we have 28 times 15. Now we've already done 28 times 10, and we've already done 28 times 5, and 15 is just 10 and 5. So you can add these products up. These are partial products of this one. So we could do it that way. 28 plus 280 plus 140 is going to be 380 and 40. I don't know. What do you think? Let's add them up. 280 plus 140. We're adding our partial products. We've got 0. We got to keep all our place values lined up. 8 plus 4, that's 9, 10, 11, 12, and 2, 3, 4. Beautiful. We get 420. Beautiful, friends. Okay, here we go. We're on our last one. It's the trickiest one. Now, I know it's 13 times something is 52. So if you're not sure, I mean, that's not that many. I could just do repeated addition. Here's my 13s over here. Oh, I think I just gave it away. I didn't mean to do that. You might be able to find this fact previously on your homework. If you can't find it, let's try some repeated addition. 13 plus 13 is 26. Plus another 13 is 9. That's 39. I'm getting pretty close. Plus another 13 is 9, 10, 11, 12, 3, 4, 5. There it is. There's 52. So how many 13s? It was 1, 2, 3, and 4. There's my 13s. 13 times 4. And you can see here is the commutative property of multiplication. We have 4 times 13 and 13 times 4. They are both 52. Okay, here we are multiplying 3 products. So I noticed that all of my, sorry, I said 3 products. What did I mean, friends? These are not products. These are the factors, and we have to find our products. So what do you notice about the factors on all of these? I notice that they're the same. We've got 2, 5, 8, 2, 5, 8, 2, 5, 8. They're all the same. Now the parentheses, we know we're supposed to do that first. So let's try it on this one. 2 times 5, we always do the parentheses first, is 10. And 10 times 8 is 80. So my product is 80. That was pretty easy. Now 2 times 8, well, I know my doubles. 2 times 8, let's do that first. That's 16. And 16 times 5. Now I could do my half trick for the 5, right? 16 times 10 is 160. And I know if I cut the factor in half, I also have to cut the product in half. So half of 16 is 8. Half of 160 is 80. So interesting. I have a match. Let's do one more. This is also a 2, 5, and an 8. So 5 times 8 is 5, 10, 15, 20, 25, 30, 35, 40. 5 times 8 is 40. And 40 times 2 is 80 again. So 80, 80, 80. We just proved our associative property. Now, I always think this is kind of funny because it really does remind me of the commutative property of multiplication, right? Where we can put our factors in any order. The only difference here is that we have 3 factors and we're moving the parentheses around. Because we're just multiplying, we can do the numbers in any order we want. So which one did you like the best? Like, which one was the easiest for you? Like, this last one wasn't too bad because I like timesing by 5 and I'm pretty good at doubling. But I actually think this one for me was the easiest because 2 times 5 is like easy peasy. That's a double, we all know. And it makes 10, which you can easily multiply anything by. So I like this one. So I might write, it says, in which order would you prefer to multiply the 3 factors? I liked A the best, and I liked A the best because I'm going to tell you, and I want you to write, and you don't have to choose A. You could choose any one you want. I liked A the best because we ought to make a 10. And anytime you can make a 10, it's easy to multiply by 10 because you just add that 0. You turn 1s into 10s. So you go ahead and write your answer. You do not have to agree with me. Okay, let's do one more of these. I think it's going to be more of the same. Look, we've got a 6, a 7, and a 10. 6, 7, 10, 6, 7, 10. Okay, let's try it. See which one we like the best. Now, what are the factors of 42? 6, 7, or my old favorite, 6 and 7 live in a shoe. It must be size 42. And 42 times 10, instead of 42 units, we have 42 strips, 42 tens. So it's 420. Now we can do this one here, 6 times 10, that's easy, that's 60. And anytime we're multiplying by a number that ends in a 0, we can just take that 0 off, right? Just ignore that 0. And we know 6 times 7 is 42. But it wasn't just 60, it was 6 tens. So we got to add that 0 back again. And I see it's going to be very similar over here. 7 times 10 is 70. 70 times 6, again, if my factor has a 0, I can just kind of ignore it. And 7 times 6 6 and 7 live in a shoe. It must be size 42. And it's not just 70, or it's 7, it's 70. So I need to remember to add a place value right there to make 420. So they're all the same. Which one did you like best? I know my answer, but I want you to write your answer and why. I liked which one? A, B, or C? Best because. Okay, friends, beautiful work. I really want you to also practice your factors and arrays on the 4th grade review page. So we're just getting that extra practice, and it won't take too long, and you can get help with from me on that page on here on YouTube as well. So excellent, friends. And if you've made it to the end, the secret shape is a cube in honor of our volume for 3-dimensional figures. So if you make a cube, you're going to get a homework bonus point. So make a little square. Draw 3 diagonal lines. Ready? 1, 2, 3. Takes a little practice to get used to doing a cube. Connect those top diagonal lines with another horizontal line, and then these side two you connect with a vertical line, and we have a little 3-dimensional cube. So bonus if you made it to the end. Well done, friends. See you in class. Bye.